to new joiners. Technical training for new joiners. Attended technical queries and contracts. We published many papers, journals and conferences. Coming to the educational background, it is PhD from NIT Surathkal in 2023 and completed his MTech from JNTU Hyderabad in 2015 and BTech also from JNTU Kakinada AP from Kakinada AP in 2009. Sir completed different projects with Vision Group of Science and Technology, VGST, Department of Electronics, Information Technology, Biotechnology and Science and Technology in under the grant of Karnataka, Project Grant 976 2022 21. Next, coming to the technical skills of our today's speaker is a designer of solar PV systems. He is a design of DC to DC converters, modeling and simulation. He is expert in different software like MATLAB, Excel, Virtual Pro, LaTeX and PV systems, Microsoft Visio, and he is strong at report writing and research papers writing. Now I would like to introduce Divya ma'am, who will give sadly to this. I request you to start your session.
Ma'am, చెప్పండి.
So, good morning to everyone.
Good morning.
Good morning. I have breakfast, right? Yeah. So, I don't want you people to get bored actually. Okay. So, I'd like to have some interactive session. Okay. Whether it is right or wrong, you know anything, you can just tell me. Okay. So, coming to this, this is Ramesh from Vari Energies Limited, working as senior manager in R&D of I just brief of me. Previously, I am in the Renaissance Senior Private Limited, Hyderabad. So recently, 3 months back, I have joined in Vari, which is in Surat, Gujarat. And coming to my educational background, as I said, I completed my PhD from NIT Surat in 2023, where my research area is focused on solar photovoltaic systems, power applications to solar photovoltaic systems. So, as part of the workshop, today I am going to discuss the application of IoT and sensor data analytics, in the sense mainly how the data science or the AI machine learning is helpful in a solar PV industry. So, before going into the actual topics, can anyone say what do you know about a solar panel actually? Or a solar module or a panel? What do you know? Just a basic. Photovoltaic cell. Okay. What do you mean by a solar photovoltaic cell? Generates power. It generates power, right? Transducer. Okay. In the new terminology, transducer. Any other? Okay. So I'll tell you what is what actually. Starting from the raw material to how the module is made and where the data science can be applied in making a solar module. Actually. Okay. So right now the session is about IoT sensor and analytics in embedded electrical system. Okay. So this is a small part of introduction as part of since it's a Sanskrit workshop, a few terminologies of Sanskrit also I'm going to use in it. So introduction culture. Okay. So IoT integrates nothing but sensors and actuators in electrical systems. So you people might be thinking how these sensors and actuators are working in a manufacturing industry. So right now the manufacturing industry is mainly on robotics. Means it is not a man-made action. Previously, in manufacturing industries, everything is dependent upon human element. But right now, almost 50 to 60% of the work is by machine over there. Only just man is operating the machine over there, but everything is automated out. So in these automated systems, you can find these sensors and actuators out there. Okay, and it enables real-time data collection, analysis, and decision making. And in manufacturing any product, there are some challenges. There are some defects in the manufacturing. There are some challenges. So to overcome these challenges, we need the data during the manufacturing process. In a sense, from starting point to the end point, how the product is made. So if you are having some data related to that automation, you can find where the defects are occurring or how the product is mainly to get the quality of the product. So if at all if you are selling any product, mainly the customer sees the quality, right? So without any quality, no one is able to purchase a product. If you want to purchase a phone, if you want to purchase a even small needle, you'll see the quality or the brand, right? So to improve further the quality of the product, the automated systems are applied with this AI or machine learning or data science to further improve the quality of the manufacturing process. And here if you can see internet Vastrava somewhere here you know that I want to integrate sensors and actuators and it's a real-time data collection. Coming to the key components of IoT and embedded systems, the key components includes whatever I want to sensors, microcontrollers, communication, cloud platform, and analytics. And what do you do with this data actually? So nowadays, I think everyone is joining data science, data analytics, they're telling it. But I think students might not be knowing what they're doing in this data analytics actually. What do you mean by data science or what do you mean by data analytics? Anyone? What exactly data science? What do you do with this data? See, like a small example I'll give you. Suppose if I want to buy a mobile, what I'll do? I'll just Google it. Spec. First, I'll go with the brand. Apple, Samsung. I'll collect the data actually. What is the megapixel of this? What is the RAM of this? What is the capacity of this? This data I will analyze, which is what a comparison will come between different brands. Okay, what is the battery capacity? What are the extra features of this? These are all raw data. I'll get it. I'll compile in a form. and I start comparison between one and the other, then I come to a conclusion. We can go with this, right? That is nothing but data analytics or data analysis. But in manufacturing industry or in real-time application, if you see, you'll be getting a huge amount of raw data. So this huge amount of raw data, if you want to analyze, you need some tools, right? And these are some applications actually where smart grids you can use it, industrial automation, where I am focusing on this industrial automation, and predictive maintenance, smart homes, healthcare devices. And these are the challenges or the opportunities in it, where the data which you are getting in the manufacturing, it needs to be secured. And one data, it needs to be integrated with other real time, it should be processing action. Okay. So now I'm going into the application point of this. Do you know what is the smallest range of its solar PV module? What is the smallest range, means watt peak of the module? A small module, what is the range of that? Anyone? Either it is 1 watt, 2 watt, 3 watt, or 10 watt, or 20 watt. Small modules, I think you can be seen in your, I mean, finally projects or something they are doing it right, small panels. So these modules will be ranging from almost 0.5 watts of AC. And do you know the highest wattage of the module? Anyone? It should be an interactive, whether it is right or wrong, you can tell anything. What is the highest peak in India? I mean, what peak, whatever we are generating? 1000 kilowatts. No, I'm talking about a module, not the solar total array size. One single module, how much it can generate? What is the highest watt peak? Roughly 500 watts? No. Right now, if you can assume it, it is nothing but almost 730 watt peak. A single solar module can generate around 730 watts of power. Based on the new technology, it is around 730 watt peak. A single solar PV module. So how is it able to generate? How we are able to generate from 0.5 watt to 730 watts a single module? Even if you can see in this building, I think there are some solar PV modules installed at the top. I think students you might be seeing it or what, I don't know. What is the watt peak of that single module? Anyone? As per my knowledge, it may be around some 330 or 350 watts. If my knowledge, okay. So right now, based on the technology changes, there are no 330 watt peak modules. Even the industry is going with minimum 550 watt peak modules. Minimum of 550 watt peak. And maximum is, right now they are going even behind that. 730, 740, 750 watt peak. Okay. So how the solar PV model manufacturing works. So before going into that, I want to tell a brief of the company where I am working with, Wari Energies Private Limited. Okay. So it was founded in 1990. Previously, it is into an electrical measurement company, measurement instruments company. So they have come with solar. So right now, Wari is India's #1 producer of solar PV modules with 13.3 gigawatt of installed solar capacity, manufacturing capacity, and cell manufacturing capacity of 5.4 gigawatt. This is India's highest manufacturing capacity. And even Wari has a manufacturing unit in America with established capacity of 3.2 gigawatt solar module capacity. It's a brief overview of Wari Energies Private Limited, which is based in Surat. These are the introduction components now. So, can anyone tell me why we are going with solar? It's cheap. Renewable energy. Since it is a renewable energy, we are going with solar. It's it's a green energy or it's a free energy available, right? So that is the main reason why we are going with solar, right? And because of the increased electrical consumption. So nowadays without AC, I think even in villages also, there is no home without refrigerator, a TV, LED TV, and an AC, right? So with this increased demand in electricity, we had alternate options are nothing but solar, wind, and hydro, right? So and abundant availability, which is free energy, is nothing but solar, and it's a clean energy. So that's why the reason we are going with solar. And anyone have seen a solar model installations anywhere? No. You know what is a warranty? Suppose if you are buying a mobile, the warranty is 1 year, right? What is the warranty of a solar module? Roughly 5 years. Okay. Madam? Roughly 5. Students? 5. 10. 10. 20. 25. 50. No, don't laugh. If I say the actual number, you will get laugh at that actually. It is nothing but 30 years. It is nothing but 30 years. Product warranties of 10 years and performance warranties of 30 years right now. Based on the technology recently, it is into 30 years. So how the solar industry is promising this 30 years of warranty? On what basis it is giving a 30 years of warranty? Because a mobile is of 1 year. So nowadays I think mobiles are manufactured only for 1 year. After 1 year again you will be purchasing a new phone, right? Right? So but solar modules, they are giving us 25 to 30 years. Previously it is in 20, they increased 25, now it is 30 years. So what is the main reason is one is technology development and the other one is quality and the manufacturing capacities and the manufacturing abilities. So that's the reason. And one more thing is testings of the model. So rigorous testings are done, rigorous R&D is done on these solar PV modules so that they can give this greater years of warranty. Okay. Now, everybody know that the basic of a solar module is nothing but a silicon. Semiconductor material silica, right, or silicon. And the basic principle is you all know that when sunlight falls on the module, some electricity is generated, so that will be given to the load. This one you people know, right? Many of the people know this. Direct sunlight is falling on that, we are getting energy, right? But what are the key components in a solar module? Only the silicon is the main important thing. Or any other components are there? Okay. So you are making the session as a one-way session, right? Okay. If you are not telling, I will be telling it. Don't worry. Right. Any other? What are the components of a solar module? How you are telling that sunlight is falling, you are collecting the energy. How you are collecting? Or if only silica, if I place here, I get the energy. No, right? So if you say these are the components of a solar module, I think you might be it is visible to you or not, I don't know. These are the components. The basic thing is a silicon PV cell. Apart from this silicon PV cell, you are having a glass, encapsulate, a backsheet, copper, tape, frame, and junction box. JB is termed as a junction box. So this is nothing but the parts of it. I don't want to tell in depth of this. Okay. History of how electrical efforts are influenced by subjects. Okay. So basically, you know that the basic important thing is of semiconductor material. So semiconductors are nothing but which are conducting in between the conductor and the insulator. These are energy parts. You can tell the semiconductors. These semiconductors are basically divided into intrinsic and extrinsic semiconductors. A pure form of silicon. So before going into the semiconductors, once again, the basic silica or the cell, how it is produced in, do you know, how many of you know that the cell is produced in India? Anyone? No. Sure. Where we are getting? China. But right now I have told that we are producing 5.4 gigawatt of solar cells, right? We are producing solar cells, but the raw material for that solar cells, sand or quartz, even the companies right now in India are not completely getting from raw material sand to solar cell. We are getting imports of wafers from other countries, and from that wafer we are producing these solar cells. So in future, maybe by 2026, Reliance and Adani are coming with a huge plan of ingot, silica sand to ingot, wafer and cell. Okay, so what I mean by I don't want to discuss in detail about this ingots or wafers and all. So this silicon solar cell, which is in a rectangular shape or a square shape, this we are getting from sand, silica. Because why only silicon apart from n number of semiconductors? Why only silicon we are going to? There's no other material apart from silicon. Why only the semiconductor material silicon is taken? Availability. Silicon is much availability, so that we are going with silicon. Okay. And this raw material, sand is further distilled, and we are getting, initially it will be mined, silicon will be mined, and it will be getting in rocks that will be crystallized into some sand. And that sand is of 90% purity of silicon, you will be getting it. And further to improve the purity, it will be further purified to get 99.98% of pure form of silicon. And from that, there is some process where the small particles will be converted into a cylinder, which is known as ingot. A huge cylinder, right? And that cylinder will be made into small parts, and it will be sliced into pieces to get the wafer. And this solar cell, by undergoing several chemical process, you'll be getting the final silicon solar cell. Okay. These are impurities and all. I think you might be knowing this. N-type or P-type semiconductor. So these are nothing but a thin film monocrystalline or polycrystalline silicon solar cells. And basically a silicon solar cell is nothing but a combination of P and N-type semiconductors. A P-type and N-type semiconductors. Why silicon? Because silicon is the most abundant element, as if I said. And you can see this, how the operation of a silicon solar cell. The first mechanism is absorption. Mobility of the electrons or mobility of the charge carriers. External conduction of current. External conduction of current. A simple thing. Absorption, mobility, and conduction of current. This is a solar cell, solar cells connection of N-type or P-type semiconductors. Right. This one I have told you, texturization, silicon solar cell. So before These are some of the steps how the solar cell is made from wafer to silicon PVC. You can see texturization, doping, PSG removal, anti-reflective coatings, contact printing, drying and firing. Okay. I don't want to tell in detail, but what I'll be telling. This is what the ingot, silicon wafer place. This will be sliced. This is what the wafer. This is what the ingot. This is, I mean, making of solar cell. I don't want to tell in detail of this. Okay. Now, these are nothing but the parameters of a solar cell. And what is it? A single solar cell produces how much watt? Roughly. Voltage. Anyone? 5 watts or 5 to 7 watts, almost 5 to 7 watts. So this is nothing but the characteristics of a solar cell, whereas it is known as IV or PV characteristics. So characteristics is nothing but how the behavior of the solar cell when the current is increased from 0 to maximum, or when the voltage is increased from 0 to maximum, how is the behavior of a solar parameters. So here the parameters are nothing but the maximum voltage it can generate, the maximum current it can produce, and the open circuit voltage, short circuit current, and the maximum power what it can generate. And one more important point is this solar cell is not a linear. Characteristics are nothing but non-linear characteristics. This is nothing but efficiency. Usual efficiency is nothing but output by input, right? Now, can you tell me what is the efficiency of solar module? Anyone? How much efficiency is the solar module? Anyone? Roughly 20%. 40 to 45. 40 to 45. 8. 72. 72. Any other answers? It is 20 to 22%. It's not 42 or 72 or 80. Previously it is almost around 15%, but right now technology is improved, so we are achieving around 22 to 24% right now. And R&D is going to increase this further to 27% even. Okay, so this efficiency is nothing but output by input. So the amount of solar insolation falling on the module divided by whatever it is generating actually. Right. So the key components, whatever I have told you in the solar PV module, the first one is the glass. Typically, tempered low iron glass is used to cover the front of the module. It's a high transparency. See, why? Because when the light is falling onto the module, okay, so few part of light will be getting reflected, right? So to get more efficiencies, right now the solar glass is made with reflective coating, anti-reflective coating. It's termed as ARC coated glass. ARC coated glass. And durability means in real-time environment, the module is exposed to different atmospheric conditions. Some dust will be falling on them, some stones will be falling on them, right? And even hailstones will be falling on them, so that glass gets break. So there should be durability of the glass. So it is nothing but a tempered low iron glass. And anti-reflective coating is used to trap more amount of sunlight into the module. and function, the glass covers and protects the solar cell from environmental damage, right? So if at all there is a no glass and all, if you are keeping just a solar PV cell in the outside, you can't even imagine what happens to it because of the harsh environments right now, right? And the second thing is encapsulant. So this encapsulant is nothing but a polymer-based material. Usually, the stages how it will be in a solar cell is in the manufacturing process. Firstly, a glass will be introduced on a conveyor belt. On that glass, there will be a layer of encapsulating material, a polymer-based material, right? On that, these solar cells are placed by connecting with copper wires. And again, on that, further encapsulating material is placed. On that encapsulated material, there is one more glass placed, and this is laminated. You know lamination, right? And then, so this will be laminated so that the solar cells are tightly fixed into in between these glass elements. Now this laminated glass material or whatever this assembly is fitted by frame across the four corners. A frame is fixed across the four corners. So why frame means to get into the installations where the installations will be there. That installation, if you want to fix, you need some nut and bolt alignment so that this frame is support for the solar module. And after that, you need to connect this current from the module. How you are able to connect? Why? That is nothing but junction box. You will be placing a junction box at the back of that. So from that there will be two terminals, positive and negative. You will be able to connect it to the load. So that you will be connecting the charge carriers of the current whatever produced from the solar cell. So this polymer based material, which is nothing but ethyl vinyl acetate, EVA they used to tell. Ethyl vinyl acetate is in the solar module, which is making it more efficient. So keeps the glass PV cells, strings, and the backsheet bonded together. Right now, technology is based on both sides of the module as glass and glass. Previously, it used to be on the top glass and the back, it is a white backsheet, material. So as the technology changed, right now we are into both sides glass to glass. Okay. So can anyone tell me what is the advantage of both sides glass to glass? More amount of energy because it can generate even from the back. When it is installed in the outer atmospheres, some part of light will be hitting onto the ground and reflected back to the surfaces. So when it is reflecting back to the surface, even the back surface can generate power. This is not a backsheet material, whatever I told, a white backsheet material previously used. And this is nothing but the frame. Whatever you are using for the solar PV module frame is nothing but an aluminum frame. It is nothing but an aluminum frame. The frame is a structural stability for the solar panel. Usually made of aluminum. A junction box, which is used as I told, it used to collect the current from the solar PV module. And in this junction box, if you see, there will be equipped with three diodes over here. Three diodes, Schottky diodes. Do you know what is the function of that? Or do you know that there will be diodes on there? So what is the function of the diodes? Why to keep the diodes on there? Remember me, I'll be telling in the next sessions. In the next time. And these are interconnecting coppers. Means when a solar module is to be made, it is nothing but a combination of different cells. I mean, different not similar cells. It needs to be interconnected, right? A single solar cell produces 0.7 volts. If you want to get 40 volts, you need to connect in a series. so that your voltage will be increased, right? So that you will be connecting this series. So to connect this solar cells in series, we use this copper, interconnecting copper. It is known as copper. And we are still reliable on China even to get this copper material. Many of the solar companies are still exporting this copper from China. You may get a doubt that, sir, why not India can produce copper? Quality. And one more thing is, demand is more and the production is less. So to meet the huge demand, we need to export from China. And these are whatever I told you. And to keep the solar frame fixed to the laminated structure, if you take one aluminum sheet and if you fix it from both the ends, you'll be fixing the laminated structure. You need some a glue to stick completely to it. Why? Because the solar module, when it is placed in the environment, or if you see on the top floor itself, you see right now how the wind is blowing over here, right? So when it is fixed onto the structure like this, see how much pressure is applied from top or bottom onto the module. With that huge wind, it can't sustain actually. So this structure, whatever it is fixed, to fix it tightly onto that module, we use a material termed as sealant. So in that frame, we'll be placing a white sealant, and that sealant will be pressed onto the module. You can see some white color sealant on it. It is termed as sealant. So with that sealant, these frames will be tightly fixed on the four corners. Onto the four corners. I want to show you a video.
That's the last side.
Thank you. The net is a bit slow. I'll continue with the section actually. So you might be thinking that he told the data analysis and all that, but he's telling about the manufacturing of solar cell and all. So now I'm going to tell where this data science is really helpful in the manufacturing process. Students, please see last benches, please. Okay. So here if you see a solar PV module manufacturing process involves these stages actually. Okay. So here, firstly, as if I have glass feeder or a glass loader. The second stage is nothing but a stringer machine. In the sense, a machine will be there where the solar cells are interconnected in series. That is termed as stringer. It is termed as a stringer, where the solar cells will be placed in some small trays in the machine. So that tray, a robotic machine will be there where it will be placed in the stringer and interconnecting coppers will be connected onto the cell axle. So that is nothing but the stringer machine. And once the strings are made, these strings are to be placed onto the module. Right? So initially the glass is placed onto the conveyor belt. Next is an encapsulate. So this assembly comes onto the next stage. So in that next stage, whatever the strings are there, every string will be picked up by the robot and it will be placed onto the module like this. Okay, so that is nothing but this layer process. Okay, now these strings we need to connect at the ends. So that is nothing but this bussing action. Okay, now in doing this process, what is the thickness of a solar cell? Anyone? Thickness of a solar cell? 0.03. It is in microns, 130 micron or 150 microns actually. So to handle this 130 microns, if by hand if you do it, if you take 100 cells, I am sure that 80 cells will be broken. You can't handle it. By human, if you want to assemble, I could take 100 cells, started connecting with copper in strings. Out of 100, 80 cells will be broken actually. So that's the reason we are into automated systems. Automated system. Everything will be automated without any human actually or there. Just keep a tray of solar cell in the machine. It only will be picking up these solar cells. It will be placed onto a small conveyor or there in the machine. it will be connecting it with this copper wire. Okay, so now after this placing onto the module, you need to check at each and every step whether defects are there or not, right? See, one example I will give you. A student joining in your first year, and there are some 4 years left for the BTech. So to evaluate the quality of the final, if you are going into an interview at the final stage, they'll be seeing your semester grade-wise marks, right? At each and every stage, what is the performance, what is the performance. In a similar way over here, from cell to module, at each and every stage of manufacturing, we need to check whether any defects are there or not. How is the quality of the product at each and every stage? So this is nothing but electroluminescence testing. Electroluminescence testing, EL testing, it is termed as. It is installed at few stages in the manufacturing process to determine the quality of the module action. Means, why I am telling this is, in the assembly of the solar PV module, if a cell is broken in between, visually you can't see it. Visually you can't find that defect. Such that the cell is broken. By this electroluminescence imaging, you can find that defect. Right. So this automation, whatever it does is, when the module is passing on to that, it will be scanning that image and it will be giving us the data. There is some software known as management effective system MES software, where the serial number of the module, the image of the EL, okay, it will be coming into that software. So I'll be taking the data and I'll be analyzing it. And by one iteration, you can't say that it is defect or not, right? See, if at all in your semester wise you are having only one exam, can we judge you? No, right? In the similar case, I have to take n number of modules. Daily, suppose if I am producing 1000 modules, I need to take some 500 modules at least to take a data, and that data I will analyze it. Means in the structure of the module, where the cell is broken. I just a small example I have taken a cell breakage actually. There are n number of defects coming into it. In the sense, if a glass is broken while handling it, you can't see it visually. That you can see it in the electroluminescence imaging. The principle behind this electroluminescence imaging is nothing but an LED. You know how an LED works, right? When you are injecting some current into that, it's a nothing but P injection diode. It will be emitting light. So, in the similar case, when the module is going on to the conveyor belt, there will be cameras around it on the bottom, and it will be focusing light on it, and that light will be captured by this camera. Then you will be getting this EL image. And based on this EL imaging itself, if there are any defects, they will be separating this defected modules or defected samples. Again, they will be doing rework. Again, they will be doing rework order. And again, the rework modules will be going on to the next stage. Right? That is what. Here I have used visual inspection. Visual inspection. Next is laminate. I have framing assembly, junction box fitting, and module curing and packing. What do you mean by this module curing? Module curing in the cell. In the junction box, if you see, there will be white forting material which is inside that JB. I have told you that there is a diodes installed in that, right? Diodes are there, 3 diodes will be there usually. Okay, and there will be white potting material inserted onto that junction box. So that is in a liquid shape actually. So why we have provided keeping that potting material is to safeguard our electrical terminals while it is installed in real-time environment conditions. Okay. So in order to make it toughened, we'll be passing into a curing chamber once the model is made, where the temperature is maintained 25 degrees centigrade and humidity is around 55 relative humidity. And next thing is partition. I want to show you a video. See, this is a step-by-step procedure. If you see, I will just formulate a few points if you want. Okay, just see the video once. Initially, this is nothing but a glass loader. This is a glass loader. There is a tray on which pallet on which glass is placed. And the dimension of the glass is 2.2 meters cross 1.3 meters. Right now, the models which are made. Okay, so this is a glass placed on the pallet, wooden pallet. Okay, and this is a robotic machine where firstly there will be a paper in between glasses. So first robot will replace the paper, it will take it and keep it aside. And next this glass will be coming into picture. See, glass is placed onto the conveyor now. So glass is going on. This is nothing but encapsulating sheet which is placing onto this glass. The a white polymer based material encapsulating which is placed onto this glass. The second stage of the process. So these are processed on to the next stages. See this. These are nothing but the strings. Different, I mean, few cells are connected in series. Along with this, these are nothing but the coppers of the It is nothing but a 4 busbar copper. Right now we have increased to 16 busbar copper. On the single solar cell, there are 16 busbars. Can anyone tell what is the reason? To collect more amount of current and to increase the efficiency, we have gone with 16 busbars. And you may get a doubt. If 16 busbars are getting more current, can we totally cover the solar module with 25 or 36 busbars? It's not. Why? Because if you totally cover the module with this copper, it can't generate. It can't generate. The 16 busbar is very much optimized to get more amount of current. To get more amount of current. See, once these solar strings are made initially and strings are placed onto the EVA, now these strings are again to be connected, right? See, I have placed 6 strings if you consider it. These 6 strings again, one by one, it needs to be connected, right? So that 6 strings will be connected by auto busing reaction, where a 4 mm or 6 mm copper will be used to connect it.
Same characteristics. Solar cells are placed in a structure comprising a front sheet of tempered iron glass, layer of EVA, solar cells, another layer of EVA, and the polishing.
This is nothing but fringe of whatever I told, where the strings are made. Cells are placed and the strings are made over.
Proximity of EVA to form typically sees the module. Reduces uses highly automated production line.
See, once the cells are placed onto it, it is passed on to the next stage. And
Ensure accurate high productivity and to minimize the risk of damage in the cells.
now one more EVA or packet is placed onto them. See, there is a visual inspection. After the laminated module, they are visually inspecting if at all if there are any defects are there or not. If any defects are there in the module, visually they can observe at 1000 lux. This visual inspection is done at 1000 lux. So if at all if any defects if they are visually they can identify this. This they will be inserting into that as software. They will be writing on there. This is the location and this is this. Location in the sense if you see over here 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. There are 12 cells connected in series over here. In that way, there are 6 pins connected over there. So the naming of this is A, B, C, D, E, F, 1, 2, 3, 2, 1 to 12 over there. So location wise, if a cell is broken over here, there will be telling as C4 location, D11, A6. So in that way, in the MES of the software, we can identify the location of the module, location of the defect also.
The many
See, this is an aluminum frame. 4 aluminum frames will be there, means lengthwise 2 and widthwise 2. Right now we have seen that one moment is flowing like this, right? So that is nothing but the dispenser sealant will be onto the. There will be one groove like that in the frame actually, where the sealant is placed on it. So once the sealant is placed, this frame will be moved on to the. It will be split at this 4, and it will be going to the module laminated structure, and it will be fixing to it.
junction nodes mounted to the rear along externally as superior.
That is the sealant placed onto the frame. See, now the frame is getting attached to the laminated structure. Now once the frame is fixed, next is to fix the junction box to the. So to paste onto that module, you need some paste, right? Glue. That is nothing but the spotting material termed as glue.
We now have functional C the foot module. The new module undergoes extensive connectivity and safety tests that uses to correctly guarantee its module for 25 years.
There happens the JB.
Feet.
And see, in this JB, I told that there will be pouring some white color fluid. Why not? Why we are pouring the white color fluid is when we are not closing it and when we are keeping it in the real time environment, there will be some dust particles sticking onto the JB inside it. So this diodes or whatever they 1x1 terminal, they will be shorted actually with this. So to avoid that, this spotting material is introduced into that and it will be cured. And once the module is made, to test the module, it is applied with high potential, which is termed as high pot test.
Speed model testing of the chambers.
I think you might be getting a few in that video actually. There are a number of videos, you can see it in the internet also. Okay. So at each and every stage, we are automated actually. So this automated needs data. And for any company, if you see, the primary goal is to increase the production, right? Without zero defects, I need to achieve some 95 or 96 or percentage of production every day. So to make that effective, I need to check at each and every stage what are the defects are going on. So how can I improve my yield, right? So in view of that, data science plays a major role over here. Data science plays a major role over here. So with this data only, I can analyze what defects are there or how efficient I can improve the quality of my product actually. See, there are n number of defects occurring at every stage. Right now, I have told you a few things actually, but there are n number of defects daily occurring in it. Means, see, you can't imagine while this making of a product, the main important thing is atmosphere. Main important thing is atmosphere. Means a small dust particle falls in the module. You can imagine, you can't imagine with your eye, some small minute thing will be falling in. Okay, externally, something is nothing but something from this leakage or somewhere, some small particle will be falling into it. Visually, you can't observe it. But that ultimately defects the defects in the EL and that reduces the output power of the module. Means it damages one or the other way, it leads to damage in the lamination process of the module and it leads to reduction in the power. And I think this question you should answer on at least this question. Do you know what is the price of a module? Price, cost. For one part, what is the price? Anything you can tell it. I am giving an open chance. You can tell 10, 20, 30, 40. For one watt, what is the price? Suppose if I tell a 500 watt peak module, what will be the cost of that? Roughly 5,000. 5,000. So 500, 5,000 means? No, I don't want the exact figure actually. Per watt. Per watt. 250 rupees is more meters.
100 rupees.
100.
Then 20 rupees. Then 20 rupees.
It is in between 15 to 20 rupees. Per watt I am speaking. Per watt it is between 15 to 20 rupees. Means if 500 watt peak, if you see, imagine the cost. 500 into 15 or 500 into 20. 500 into 20 in the sense 10,000, right? Right? And say, you should be familiar with this, at least the cost of the module, or cost per one watt peak. And have you heard this PM Surya Ghar Yojana scheme? Anyone? Right? So, Indian government has announced that 1 crore homes with solar installations where they are giving incentives for that. For 1 kilowatt system, 30,000. I don't know exactly the figures. For 1 kilowatt, 30, and for 2 kilowatt, it is 60, and about 2 kilowatt, it is some 75,000, I think. Do you know this? Right. So in this way, each and every, see, not only since I am from solar background, I have explained the solar manufacturing process and the importance of data analysis in it. But in every industry, whether it is irrespective of the product, you can apply data science in it. Because nowadays, every manufacturing industry comes with automated systems, and they are trying to improve their quality and standards. So to improve their quality and standards, definitely we need automation, and for this automation, we need data science or machine learning or a tools for this. Any other queries from this?
What is the problem of radiation? Radiation is something foreign instant. So directly you can't get that connection. So between the quantity, software, you can see then what next what's what is the next stage?
No, the stage is nothing but see, if you want to install a 1 kilowatt system.
Yes.
So 1 kilowatt system is roughly I need some 2 500 watt peak modules. So 2 500 watt peak modules I'll be installing. Okay. So it will be connected in series. Means the positive negative will be connected to next positive, and next negative will be there. So I am having a positive and negative question. So this will be connected to an inverter. And from that inverter, you will be getting a single phase AC output, and that will be given down to the load. That is nothing but the process. And based on your installations, based on your climatic conditions, you will be placing your model in different direction where the sunlight is falling onto the model. Usually, the tilt angle in general in our Hyderabad is around some 15 to 18 degrees. 15 to 18 degrees. The tilt angle of the model. You can't place like this, right? Horizontal. And what is the color of solar cell? Blue. Why are we blue? Do you know what is that? Do you know that silicon will be in blue color? Silicon will be in gray color actually, if you see. But how this blue color is coming into picture? See, that what? As if I said, our main target is to trap more amount of sunlight, right? Means the material whatever is made to trap more amount of sunlight. Firstly, the glass is a structure which is falling. The sunlight is falling onto the glass. So if glass is with ARC coating, anti-reflective coating, more amount of sunlight gets. And after that is an EVA, encapsulated material, polymer-based material. Okay. So that encapsulated material, the primary important property should be it should be having high light transmittance capacity. High light transmittance capacity should be there for that EVA. You can't take any polymer material, whatever you want. It should be having high light transmittability. So when high light is transmitted from that EVA, next is nothing but your solar cell. And this solar cell, to improve more efficiency, again the solar cell is based with anti-reflective coating. When solar cell is made, there is some anti-reflective coating over even the solar cell also. Because of that coating only, we are getting this blue color. Anti-reflective coating, usually. There are some solar cells which are in black in color, but A general phenomenon, whatever we use for the anti-reflective coating is a blue color. When this gray color vapor is placed, went with reflective coating, it will be becoming a blue color. It will be a blue color. And this anti-reflective coating makes more amount of sunlight to fall onto the module. So when more amount of sunlight is falling onto the module, more charge carriers are developed, so that more amount of current is generated. This is what the technology. Right. And right in solar cells, I don't know. I think when I'm studying also, I don't know what is this technology and all. Right now, since I am there, I know the terminology of the technologies and all. Okay. So right now, the solar technologies are perfect. Cell is nothing but if you want to go and purchase, you will be asking based on the I need a 2.4 gigahertz model of this chipset Unisoc processor or some processor like that. You will be telling it right. In a similar way, if I want to purchase a module, I need to know what technology I need to purchase. So in market, there are monopod modules, top-con modules, and right now technology is HJT, heterojunction technology. But the next is heterojunction technology. Right now, the market is with top-con technology, tunnel oxide passivated contact. Tunnel oxide passivated contact technology, top-con technology, which is with high efficiency solar cells. High efficient solar cells. So before tunnel oxide, it used to be passivated emitter rare contact cells. Rare contact cells. And to just give you an information, the next future technologies are nothing but cell technology. They are trying to go with zero busbar technology. I told you 16 busbar, right? So what is happening in this 16? Before going into the 16 busbar, I'd like to ask you a question. I told that diodes will be there in the junction box, right? So this is the right time. Why the diodes are there in the junction box? Switching action, right? Diodes are nothing but a switching action. So here also, what is the need of diodes switching action of cases?
Conversion process.
Okay. Reverse correct. See, the main problem for solar module is it is not used inside, right? It is exposed to sunlight. So when it is exposed to sunlight, there is some dust falling onto the modules, right? And there is some shade falling onto the module. If you are installing, as if I said, I think I had a suggestion for your madam also. I think I have seen from my place where I am guest room. I have seen the module staying over there. There is some shadow falling onto the modules actually. If I am not sure roughly, there is some antennas near the panels like this. So you will be thinking that what happens? Well, nothing happens to the module because of this antenna, but the shade of this antenna falls onto the module. At some point of time, it continuously falls onto the module, and the cells, whatever are there, it will be continuously covered onto the module. Means in that there is no current generated from the cells, right? So when there is no current generated from the cells, there is no power output from the cells. The power output from the cell gets reduced. So frequent maintenance has to be done, right? For us also, to get frequently, you have to update yourself, right? So frequent maintenance has to be done for the modules. But what happens to this bypass diodes is, in general, right now, if you see, the cells are placed in half cut mode, and whatever the module I have shown, in the next session, even I will show you a big picture of the module that you can easily identify. Right now, a full cell is not aligned in the module. A half cut cell is again in the stringer machine, it is cut into half, and it is made into strings actually. Because of to reduce the partial shading effect onto the modules, they are made into half cut cells and arranged into the module. And you can see two structures onto the module. Means previously, if this is the module, a single JP used to be at the top. Right now, if you see the module, the JP will be at the middle. JP will be at the middle. Observe it. Right now, the module comes with junction box at the middle of the module. Why? Because the module is divided into two parts. See, I told your module is there at the top, right? So whenever a cool shadow is falling onto the one module, previously a single junction box over here, a single one. If a shade is falling onto the module and the total cells are covered at the end of the module, the power output will be zero. But right now, when you have divided this into two halves, even if a shade is on the one side of the module, it generates half of the power. It is able to generate half of the power that is made by this diodes. This diode functions in those cases. A bypass layer means it bypasses one side and it operates onto the next side as well. I'll show you the pics if you want in the next slide. Okay, so this is the main use of a bypass layer. So just have a break, we'll continue in the next slide.
Thanks for that's very good advice, Mary. Hopefully, it's like it's not sort of technically and thanks for the hand. And then, go back, but